Hi everybody. In this video you will find the content of a talk I had the pleasure to give, together with Diederik Aerts, at the 8th International Workshop on Quantum Mechanics and Quantum Information, organized by the International Network on Foundations of Quantum Mechanics and Quantum Information. With Diederik, we were already on board for its 7th edition, during which we talked about the conceptuality interpretation of quantum mechanics, emphasizing that the core mystery of quantum mechanics is non-spatiality, the fact that quantum entities can be associated with potential modes of being, that is, with non-spatial states. And we also emphasize that the main mission of the conceptuality interpretation is to provide a possible understanding of what could be the nature of entities that can be in non-spatial states. And the speculative hypothesis that such nature would be conceptual, although, of course, not to be understood here in the sense of human concepts. This time, we consider the other great scientific revolution of the beginning of the last century, relativity, to show that also relativity forces us in some way to abandon a purely spatio-temporal description of our physical reality, although for different reasons than quantum mechanics. In other words, quantum mechanics and relativity join forces, so to say, to tell us about the existence of a non-spatio-temporal real, which would be the true seat of the processes of change experienced by the different physical entities. Now, we did so by considering what we have termed the luminiferous elephant in the room, that of the invariance of the light speed, Einstein's famous second postulate. The question is, how is it possible that a finite speed is measured as having always the same value, regardless of the reference frame used to measure it? Well, if that doesn't surprise you, then let me tell you, you haven't been paying enough attention. Before I begin with the presentation, a little warning. What I will tell you here is very simple, and in part is also well known, as the purpose is not to rewrite relativity or explain all of it, but simply to try to take more seriously what it possibly tells us. What I'm going to say is very simple, but I will introduce many notions and many reasonings which will lead you to reflect on the subject of time and space in a way that you are maybe not used to. So everything is very simple and at the same time pretty subtle. And it could be a lot of stuff to digest just in one go. So maybe listen to the presentation several times and above all consult the references that I will indicate in the description of the video. Have a good listening. Let me start with a famous phrase attributed to my fellow countryman Galileo Galilei. And yet it moves, eppur si muove. He apparently said that when he had to retract his claims that, following Copernicus, the motions appearing in the firmament were the consequence of Earth's motion. Now, this phrase is interesting because it points to one of the difficulties in accepting the new Copernican view, that humans do not directly perceive the movement of the planet. If this was indeed the case, then of course Galileo's perspective would have not been controversial, but just experimental evidence. But what we consider as experimental evidence also depends on our conceptualization of the world. So much so that ideas about what would be the effects of a moving Earth, say on the trajectory of projectiles, and the lack of observation of these effects, were considered at the time to be evidence of the falsity of the view of a planet moving around the Sun and spinning on its axis. What was underestimated at the time of Galileo was the fact that everything on the planet's surface was moving with it, including its inhabitants, and therefore the latter could not perceive with their senses, nor with elementary experiments, the planet's motion. Now, what is important here to emphasize is that Copernicus and Galileo, they revolutionize our view on movement by allowing us to become aware of the existence of movements we were absolutely unaware of. And this not because they were hidden. In fact, as Allan Poe famously emphasized, the best place to hide something is often right out in the open. We humans were all openly moving, together with the planet, but precisely because of that, we were not able to detect the planet's motion. And this brings us to the next great revolution about movement, that of Einstein's relativity. But in our view, such revolution has not been fully accomplished, because what most physicists do not seem to have fully appreciated is that the material entities move much more and rather differently than the way Copernicus told us, because they also move extremely swiftly in the time dimension. But since they do so all together, this is why, similarly to what happened centuries ago, we do not perceive such movement. Okay, but let me start by describing the elephant in the room, the constancy of a light speed. Take two cars traveling with opposite velocities on a road. What you have just seen on the screen is their movement from the perspective of a frame of reference, sigma, associated with the road. And the velocity v and minus v are those we usually consider as good velocities, bona fide velocities of material entities, and are sometimes called coordinate velocities, because they are calculated using the coordinates t and x of the reference system in question, here the system of the road. Consider now the same physical situation, but seen from the perspective of one of the two cars, say the yellow car. That is, from the perspective of a frame of reference, sigma prime, associated with the yellow car. Because of the Galilean composition law for velocities, which is additive, the driver of the yellow car will see the blue car approaching at velocity v prime equals to 2v. But the Galilean composition law is just an approximation of a more general, non-linear composition law for the velocities, here written just for the special situation we are considering. This more general law approximates the Galilean law in the non-relativistic regime, that is, when speeds are small compared with a light speed. But when speeds approach the light speed c, something very strange happens. The composition of velocity fails in this limit, in the sense that in both frames, sigma and sigma prime, speeds are observed to be exactly the same. Again, if that doesn't surprise you, then you haven't been paying enough attention. A first possible way out of this apparent paradox of a finite velocity c which is observed to be exactly the same by all the moving participators is to write the Lorentz transformation in a different way. It is straightforward to check that they can be equivalently written as hyperbolic rotations, introducing for this a hyperbolic angle capital theta, equal to the inverse of the hyperbolic tangent of capital V over c, with capital V being here the velocity of the sigma prime reference frame. Considering then a car moving at velocity v with respect to sigma, the velocity v prime with which it moves with respect to sigma prime is of course given by the relativistic composition law. But we can then also associate three hyperbolic angles to the three velocities v, v prime and capital V, and following Alfred Robb, the Northern Irish physicist who back in 1911 gave a derivation of relativity theory in an axiomatic geometric way, so much so he was called for this the Euclid of relativity, we can also introduce three velocity-like quantities that Robb called rapidities by simply multiplying these hyperbolic angles by the light speed c. And since angles are by definition additive, these rapidities will naturally obey the Galilean composition law. And this is not anymore a non-relativistic approximation. Now, rapidities converge to the standard definition of velocity in the non-relativistic regime. But differently from coordinate velocity, they are not bounded, and the magnitude of the rapidity of light is infinite. In other words, the rapidity of light is not, strictly speaking, an invariant,
since it obeys the Galilean linear law. But since its magnitude is infinite, it is necessarily the same in all reference frames, because adding or subtracting a finite number to an infinite number, well, it has no effect. Now, I must admit, this solution of the luminiferous elephant in the room paradox for many years satisfied me, and it was only in more recent years, when discussing of these topics with Diederik Aerts, that I realized that although it contained the seed of the solution, it was not the right answer. Indeed, velocities have little to do with angles, and a solution in terms of rapidity really seems to me now a bit too ad hoc. But the idea that a correct notion of velocity would confer an infinite speed to light, this seems indeed to be the right way to go. Now, the revolutionary passage from Galileo relativity to Einstein relativity corresponds in particular to the passage from a single time, valid for every reality's participator, to a multiplicity of different times, which can be associated with the different inertial participators or observers, and more generally with the different physical entities. So, when we calculate a velocity, a new problem arises. With respect to which temporal variation should one calculate the variation of the position of a physical entity? Coming back to our car, we can observe that every modern motor vehicle is equipped with a so-called speedometer, an onboard instrument that allows to measure the distance traveled per unit time. Now, a speedometer is an instrument with a built-in clock, so the time it uses is that of a clock traveling with a car. To describe the situation, we have to introduce a reference frame, sigma p, associated with the car moving at speed v with respect to the reference frame sigma associated with the road. We can then denote vp, the velocity of the car, as measured by the speedometer, also called celerity or proper spatial velocity. As it was the case for rapidities, celerity are equivalent to coordinate velocities in the non-relativistic regime. And as for rapidities, celerity are not bounded by a limit speed. And if we measure the speed of light with a speedometer protocol, that is, if we measure the proper speed of light, or its celerity if you prefer, it will no longer have a finite value, but an infinite one. Using Lorentz transformation, it is then not difficult to calculate the composition law for the celerities, which is a nonlinear law. And of course, in the non-relativistic regime, we recover the usual Galilean additive law. What about the elephant? Again, the problem no longer exists, because compatibly with the asymptotic form of the celerities composition law, multiplying a positive or negative infinity by a positive constant has no effect. So what we have is that the celerity of light is infinite and varies infinitely when we move from one inertial frame to another, but the infinity of its variation drones in the infinity of its value. So, we distinguish three different spatial velocities: the standard coordinate velocity, rapidity, and celerity, or proper velocity. Standard coordinate velocity is problematic because it leads to the paradox of an invariant finite light speed. Rapidity, as suggestive as it might be, solves the luminiferous elephant in the room problem, but can hardly be considered to be the natural relativistic generalization of the common notion of coordinate velocity. On the other hand, as we will further motivate, the notion of proper velocity Vp, or celerity, is what we believe is the right candidate, the notion one should use to characterize the spatial movement of an entity. And if this is so, we can now easily understand why the light-speed paradox emerged in the first place. There is no difference between the standard velocity and celerity in the non-relativistic regime, so we had no way of becoming aware that we were using an improper velocity notion before the advent of relativity. An improper notion because it contains an undue contraction that we were not aware performing in pre-relativistic times. In other words, a quantity whose range should naturally go from 0 to infinity was contracted into a quantity with now a bounded interval going from 0 to c. So, if the coordinate speed of light is always equal to c, this is because the contraction in question is calibrated in such a way to always obtain that same finite value c. Okay, I have to mention now a second elephant in the room, this time in the mathematical room of the formalism of relativity theory. Because there is an important notion in relativity that we all know, that we all have studied, which is called the four-velocity. It extends the notion of celerity as measured by the speedometer, which, as we have seen, allows to solve the apparent paradox of the constancy of the light speed. The spatial component of the four-velocity is indeed celerity, the proper spatial velocity, but there is an additional time component, describing a movement along the time direction, that is, along the proper time direction of another entity to which the reference system in question is associated. And there is a remarkable fact. When we calculate the magnitude of the four-velocity using the Minkowskian metric, which has a minus sign for the spatial variables and a plus sign for the time variable, we obtain that it is exactly equal to c. Now, some of you might have had the experience of asking the professor during a relativity class if the four-velocity is a true physical velocity. A possible answer could have been that, since our physical reality truly happens only in space, well, this is the usual prejudice, it certainly cannot be interpreted as a physical velocity. Another possible answer is the notorious "shut up and calculate," or more politely, "please, just calculate." And regarding the remarkable result that the magnitude of the four-velocity is always equal exactly to c, this is usually considered to be just a mathematical property related to the fact that the Minkowski norm is a Lorentz invariant. And in any case, in the mind of physicists, c already has an interpretation as the coordinate speed of light. But is it really true that reality is just in space? And if we consider reality to be more generally in space-time, how can we even speak of a movement in space-time? And what does a four-velocity represent in relation to such a hypothetical movement? Certainly, if we all move at the same force speed, then, like it was the case for the Copernican revolution, this is something it would be very difficult to become aware of. So it seems there is really another mystery to elucidate in relation to this second elephant in the spatio-temporal room. To do so, and to continue our investigation of the nature of movement in relativity, it is important at this point to answer the following fundamental question. What is real? In the sense of, what is real for a given entity in a given moment? In a nutshell, this corresponds to all that is available to be experienced by such entity in that moment. For example, if the entity is a skier, so a human participator, something available to be experienced could be a ski jump. Now, there are two fundamental aspects in an experience, a creation aspect and a discovery aspect. More precisely, what we call a creation is that aspect of an experience that is acted upon by the participator. Then there is that other aspect of an experience that lends itself to such action, being present independently of such action, which we can call a happening, and which therefore can be discovered while performing such action. So, an experience is determined by the joining, the fusion, if you will, of a creation and a happening, with the former being usually expressed by a verb and the latter being usually expressed by a substantive. The crucial point in our reality construction is that although a participator in a given moment can only have one experience, there are many experiences it could have had in replacement of its present experience, if only it would have made different choices in its past. In other words, Although there is only one happening which, together with a creation, form the present experience of a participator, many other happenings are also jointly available in that same moment to be part of its present experience. For instance, the wood and the ski jump are two happenings jointly belonging to the personal present reality of the skier. Depending on the decision it made on its way down, it could either have had an experience with the ski jump or with the wood, which therefore are both part of the skier's present personal reality in a given moment, although they cannot be jointly experienced by it. The collection of all these jointly existing happenings that the participator could have discovered in a given moment, which are all jointly available, all simultaneously available to participate in its present experience, such collection constitutes by definition the present personal reality of the participator. So, we really construct our personal reality from all our potentially present experiences, and in a sense we could say the substance of which our reality is made of is possibility. Participators, by choosing, they bring possibilities into existence which in a sense are made of their own choosing. Now, of course, not all happenings are spatial happenings, so this operational definition of the personal reality of a participator, it already extends beyond our usual spatial representation. But even when we limit our analysis to those specific happenings that only happen in space, we already see that the present personal reality of a participator is more complex than what we are used to consider. Let me explain. Consider two clocks, a yellow clock and a blue clock. Let us assume that I am sitting in my office and that the yellow clock is in my pocket, whereas the blue clock is in my desk drawer, and that they are synchronized. They both mark the same time. Let's say 13 o'clock, which is my present moment. In other words, the yellow clock and the blue clock, both marking 13 o'clock, are jointly part of my personal present reality at 13 o'clock. And as I have just explained, this is so because both clocks are available to become part of my experience. For instance, 5 seconds before 13 o'clock, I could have either decided to take the yellow clock out of my pocket and look at it, assuming the operation takes 5 seconds, discovering in this way that it marked 13 o'clock. Or I could have decided to take the blue clock from the drawer, assuming again that the operation takes 5 seconds, and look at its face to also discover that it marks exactly 13 o'clock. So far, so good. But it is also true that an hour before, so 5 seconds before 12 o'clock, I could have decided to travel back and forth along a given direction in space. And when I say space, I mean here space as defined by the reference frame associated with my office. And I could have done so, for example, at celerity Vp. And let us assume for simplicity that I was also able to elastically revert my path after exactly half an hour. If I would have done so, then, when back at my office at a personal time corresponding to 5 seconds before 13 o'clock, I could have decided to either look at the yellow clock in my pocket, discovering that it marks 13 o'clock, or to take the blue clock from the drawer. And by looking at it, I would have discovered that it doesn't mark 13 o'clock, like the clock in my pocket, but 13 o'clock plus capital T, where capital T is given by the usual time dilation formula, here expressed using the proper velocity. And of course I could also have decided not to travel back and forth, or I could have decided to do so at a different celerity Vp prime. Then again, I could have decided to either look at the yellow clock in my pocket, which would always mark 13 o'clock, or to take the blue clock from the drawer, which would then mark 13 o'clock plus a time capital T prime, which can be calculated using this different celerity, and so on. In other words, different temporal versions of a same entity, here the blue clock, will coexist in the construction of my personal present reality, which in that sense is describable as a Minkowskian four-dimensional block universe structure of events or happenings. But we are not describing here a frozen, static version of a block universe. The view remains fully dynamic, in the sense that the future of an entity is not given. Entities of different ages exist in my personal present reality, but within the limits of their lifespan, for as long as they are not destroyed. And the entities that have not yet been created also do not exist, as they are not happening yet. So, it follows from this analysis that if we take seriously the way we operationally construct our personal present reality, as a collection of happenings that can possibly be fused with our creation, and consider what relativity tells us about time dilation, we cannot anymore stick to a description of the different material entities in a three-dimensional Euclidean spatial theater, but really need to shift to a genuine four-dimensional spatio-temporal representation. But then, how do we move in such spatio-temporal extended theater? For this, we need a notion of velocity that can describe a movement in four dimensions, in a four-dimensional spatio-temporal theater. And that's of course the notion of four velocity, which, as we saw, naturally extends the notion of celerity as measured by the speedometer, and has a magnitude which is always equal to c, and is telling us that every physical entity always moves, relative to the whole space-time, at the same proper speed, which has coincidentally the same value as the coordinate speed of light c. Always in the sense that this magnitude of the four velocity does not depend on the choice of the reference frame. Hence, it is truly an intrinsic property of the moving entities. Now, what is the four velocity of light? We already know that its spatial component is infinite. Hence, also the time component is infinite, and these infinities exactly compensate when calculating the norm of the four-velocity vector, which has to be equal to c. What about a body which is at rest in a given reference frame? The spatial component of the four-velocity, its celerity, will then be zero, but the time component will not be zero. Even when spatially at rest, an entity continues to move at proper speed c in time. It is in fact this movement which represents the dominating component of the four velocities of the low spatial speed objects we interact with in our everyday life. So, as we anticipated in the beginning, this is the part of the movement of an entity that remains unnoticed following Copernicus' revolution, and we think still remains undervalued today. But is this a real movement? Well, if it is so, then some energy has to be involved in it, right? To see this, let us consider the notion of four momentum, which is simply given by the rest mass times the four velocity. Note that the four velocity retains in the relativistic regime the interpretation of being equal to the momentum of an entity per unit of its mass, which is obviously an extra sign that this is the correct physical notion to use. Clearly, the four momentum being the rest mass times the four velocity, and the magnitude of the latter being equal to c, the magnitude of the four momentum is the rest mass times c. And energy, as is well known, is given by the relativistic mass times c squared. What happens then to an entity spatially at rest? Well, only the time component of the entity's proper momentum will be non-zero and equal to the rest mass times c, which corresponds to energy m0 c squared. This means that all the energy contained in the entity's rest mass can be interpreted as the energy associated with its motion at proper speed c along the time axis, therefore as temporal kinetic energy. So, we can say that the energy extracted in nuclear reactions, in ultimate analysis, is time energy. Okay, so we have argued that the standard notion of velocity, coordinate velocity, should be replaced by the notion of celerity to solve the luminiferous elephant in the room. And when considering the way we construct the personal present reality of a participator, or more generally of any material entity, here non-quantum, we have seen that we have to extend celerity into a proper four-velocity, as we need to describe a movement not only in space, but more generally in space-time, with the temporal component of such movement which usually dominates. And by the way, from that perspective, a spaceship should be primarily called a time ship. We have also observed that all material entities move relative to the different reference frames always at the same proper force-speed c. This means that, starting with a conundrum that we have called the luminiferous elephant in the room, and by proposing a solution to it, we have become aware of a second elephant in the room. This time the room is not just a spatial room, but a spatio-temporal room. Indeed, we need now to explain how the material entities can all travel at the same spatio-temporal speed c, whether they have a zero rest mass or not. So, ironically, by solving the apparent paradox of the constancy of the coordinate speed of light, we ran into a similar paradox, that of the constancy of the force speed of all material entities, not just light. And if we take this seriously as something profound about our physical world, then we are forced to admit that all these movements, all happening at the same force speed c in every inertial reference frame, and also of course locally in the non-inertial ones, that they cannot occur inside the different space-time theaters, but in a more abstract non-spatio-temporal realm, or pre-spatio-temporal realm if you prefer. This also because, observing that the standard coordinate velocity has to be replaced by celerity, we have also to abandon the view that coordinate velocity brings with it, that entities would move inside the spaces associated with other entities. In other words, the solution to the problem posed by the second elephant in the room is to posit the existence of a non-spatio-temporal reality in which the actual evolution of the physical entities happens. This means that by taking relativity seriously, we have to proceed similarly to when we take quantum mechanics seriously and try to really explain non-locality and the related phenomena. But then, is it possible to imagine this non-spatio-temporal reality? Well, we can think of it as the equivalent of a semantic space, with entities cognitively evolving on it. And I'll come back briefly on the soundness of this hypothesis in the very end. So, imagine a yellow participator needing 8 conceptual steps to reach a given conclusion, starting from a given hypothesis. And imagine a blue participator only needing 4 conceptual steps to reach that same conclusion, starting from that same hypothesis. We have to imagine these conceptual steps as being actualized all at the same pace, in the sense that the yellow and blue participators both reason at the same speed, the difference being that the blue participator is more effective in reaching the conclusion, as it does so by using fewer conceptual steps. More concretely, we can think of this semantic space as a web of meanings, similar to our World Wide Web, with each of its pages containing a different story, with a different meaning. And then the yellow and blue participators are like surfers on such web of meanings, clicking on the different hyperlinks at the same frequency. We really have to think about the yellow and blue participators not as objects in space, but as cognitive entities with meaning-driven interactions. And please note that I am not here using the term cognitive in the restricted human sense. Okay, imagine now that the yellow participator wants to keep track, in an orderly manner, of its conceptual path, by introducing an axis to parameterize each one of its conceptual steps, each one of its elementary experiences. This will be a personal time axis, where each conceptual step will have a same given length, such that the frequency of the clicking times the unit length is exactly the speed c. Now, we know that the blue participator does not follow the same conceptual path, but it reaches the same conclusion, the same web page, by following a shorter conceptual path, only making 4 elementary steps instead of 8. Imagine then that the yellow participator also wants to keep track of the cognitive path followed by the blue participator, in addition to its own. Obviously, it cannot do so on the same axis used to parameterize its own path, as units were precisely chosen there so that one needs 8 conceptual elementary steps to reach the conclusion, and not just 4. Therefore, to consistently parameterize the cognitive evolution of the blue participator, it has to introduce an additional axis, and use the additional dimension generated by such axis, which then becomes a space axis, to describe the blue participator as moving on a round-trip path. And in this way, the yellow participator has now contextually created a personal space-time in which it can consistently describe the cognitive activity of the blue participator and put it in relation to its own. Of course, such construction cannot be Euclidean, because if this would be the case, the length of the conceptual path of the blue participator would be longer, whereas it must be shorter, because the blue participator follows a shorter cognitive path, only using half of the conceptual steps used by the yellow participator. Hence, a pseudo-Euclidean construction needs to be used, and more precisely that specific pseudo-Euclidean construction known as the Minkowski space-time. And from the perspective of this contextually created personal spatiotemporal construction, the blue participator produces elementary conceptual steps taking more time than those of the yellow one. But since it also uses less steps when progressing in the semantic space, they are still able to spatiotemporally meet again at the common conclusion. Now, one would be tempted to say that the blue participator moves at a given coordinate velocity inside the personal space of the yellow participator, as its space-time diagram seems to suggest. But this, we think, would be a wrong image. The right image, or at least part of the right image, is what the science officer Spock says to a young Scotty when explaining how transwarp beaming works. Scotty suddenly realizes that it is space, and not what is apparently in space, that moves. And this is the image that also emerges from our analysis. The different material entities contextually create their personal spatiotemporal representations, and by incessantly all moving in a more abstract non-spatiotemporal reality, they bring with them their own evolving present, their own space-time, similarly to how a turtle takes its little house with it. Hence, we do not move in space or in the space of other entities. The different personal spaces, and more generally space-times, constantly slide, so to say, over each other, mutually interpenetrating. Then, what about quantum entities? Well, when we move from one page to another on the web of meanings, by clicking on the different hyperlinks, we move in an already collapsed reality, and can just explore a subclass of all possible meaning connection, those available as clickable hyperlinks going from one web page to another. These web pages are like stories. We can think of them as large aggregates of meaning-connected concepts. But of course, on the opposite side of the conceptual spectrum, we also have more abstract concepts, single-word concepts, two-word concepts, three-word concepts, and so on. We have all sorts of intermediate aggregates expressing different degrees of abstractness or of concreteness, so different layers of a truly quantum web. Hence, the classical time-space duality must be replaced, when dealing with quantum entities, by a more general duality between time and the set of outcome states associated with a different possible measurement, describing, for instance, how more abstract concepts can be collapsed into more concrete ones. We cannot, of course, enter into all that here. But it is certainly here that we connect with the content of the talk we gave last year, which was about the necessity of interpreting quantum mechanics using a cognitivistic and conceptualistic approach, which in our view provides the missing metaphysics and ontology for explaining the strange behavior of quantum entities. In the sense that elementary physical entities would be conceptual in nature, and the entities made of ordinary matter would be cognitive in nature, and that the mind-language duality of the human cultural domain mirrors the fermion-boson duality of the physical domain, in the sense that bosons and fermions would be entities belonging to a more ancient proto-cultural domain, where bosons are the natural building blocks of languages and fermions are the natural building blocks of cognitive entities. This means that our world would be fundamentally pancognitivistic, in the sense that everything in it would participate in cognition, with human cognition being just a very recent episode of it, expressed at a very specific organizational level. And we think it is not by chance that a conceptual turn is also needed if we want to really understand relativity theory. Thanks for your listening.